Susie,
Rob,
are you real or are you an AI generated paleontologist?
I think I'm real. Although now I've got are we living in is the world real?
Ow, ow,
I don't
ow.
know.
Okay. I don't
Oh
know.
my
I don't
God.
know. How could
We're
we
gonna have
test? Is there a way we could test to figure out what AI could do? Can AI tell us some paleo jokes?
Well, actually, Rob, I asked ChatGPT to tell us
Okay.
some AI paleo crossover jokes.
hmm
This is the first one. It said, why did the paleontologist refuse to use the AI tool in the field?
I don't know. Why did the AI paleontologist refuse to use the tool in the field?
No, the paleontologist is not AI. Anyway, the answer
Okay,
is
sorry.
because every time it found a fossil, it yelled, reconstructing, please wait 65 million years.
Tumbleweed
So,
sounds.
so I
Tumbleweed sounds.
said to ChatGPT, that's not very funny. Have you got another one? And so it
Ow,
said,
ow, ow. Okay.
it said, of course.
Of course.
Paleontologist, AI, can you help me identify this fossil? AI, certainly. Based on my analysis, it's really old. Paleontologist, yes, but what is it? AI, obsolete hardware.
Hmm. Okay. Now, I don't know if that means that AI can't do jokes or can't do
Yes, that's what it
paleontology or
means,
can't
Rob.
do both. All right. Okay. Well, that's going to be the theme of today's episode, I guess. Right. Okay. So that we're introducing the theme for today was to call, are paleontologists going to go extinct, or can we? What are the opportunities for AI, right, in paleontology? So I guess AI is everywhere, right? But before we go into that, I guess we should catch up briefly after we were. I can confirm that you're not indeed an AI sprite because we were talking to
Thanks.
each other SVP in person, right?
We
So
were. It was nice.
that was nice. So that was a level of sophistication of that. I don't think AI is ready yet to create a walking Susie Maidment bot. So I asked ChatGPT who or what Susie Maidment is. First of all, it surprised me it said it didn't know. But then I asked who is Susie Maidment, paleontologist. And then it did give some information on you and explained that you're working on sauropods all the time, which have you worked on sauropods?
I've published two papers on sauropods. One,
Okay.
I didn't actually have any input in the sauropods. It was a Paul Barrett paper in which it was about sauropods. And then at the end, he went, also some information on the ornithischians. And then I did that bit.
Okay. Well, it also
But
says
that's
that
it.
I work on Devonian fish, which is correct, but it also says I work on land fish and tetrapods on land, which was not true. So I'll allow that. But I also asked it what the fossil files was, and it was in at least it seems to give a different answer every time you ask it. But the first answer it said was it's Susie Maidment's podcast. So Susie Maidment is a paleontologist. She does lots of Susie Maidment things and did not mention me at all. So Chat GTP needs to get in the bin. I'm a bit annoyed about that. So I guess that's the context we're trying to set up for today was that we want to think about what the opportunities and risks for paleontology are in respect to AI. Can it make us unemployed? Or is it going to make our jobs very much easier? So we were going to introduce one particular paper, but I need to warn you, it's not been a great week here. I fell off my bike and damaged my ribs. So you're not to make me laugh too hard because it hurts. So
I forgot to
please,
ask you how the ribs were today. How were the ribs
can we
today?
be can we be less funny this time, please? And no, don't. It hurts. And to make it even worse, my 8-year-old is off school at home downstairs because he was sick at school yesterday and has to stay home. So I don't know how long Zelda on the Nintendo can keep him occupied. We'll see if
Oh, I
it's,
reckon quite a long time.
I reckon, quite a long time. So just a warning.
Okay.
How did your field trip to SVP go?
It was lovely, actually. We had a lovely time. The weather
Okay.
remarkably was beautiful, and we did lots of fun things. We visited lots of interesting UK dinos focused places. Got to see trackways and
Nice.
some nice dinosaurs, and yeah, it was lovely. Very enjoyable. Had
Well,
some
fossil
cake.
trackways, that's going to come up in today's paper. That'll be good. So the paper we're going to be looking at is a review article from last year. So that's a bit naughty because we normally try and do research articles and normally much more recently than that. But I will stick to the format by putting a few more in. So this is by Kongyu Yu, sorry, and a lot of other colleagues from all over the world, lots from China, some from Bristol, some from Scandinavia. This was published in Earth Science Reviews in April 2024. So, artificial intelligence and paleontology is a review article. So, a review article is a bit different from a research article. Most of the papers we've done so far is like a piece of research that's been done. A review article is a bit different, where they sort of take a sort of study of the field and sort of present a consensus of what the current state is and opportunities and risks and what's gone on before. So that's kind of fun. So in this paper, they start by introducing some of the background of AI, talk about history, talking about some examples. And I think what's useful for me is that they talk about some of the different methods and techniques in it. This includes a lot of acronyms. I mean, had you come across any of these acronyms before?
I had come across some of these before a little bit because I am sort of tangentially involved in a project working on developing methods for AI for image segmentation for CT scans. And we have an AI unit at the Natural History Museum. So they actually have a whole, they facilitate research using AI and developing different AI methods. But I have to say, having said all that, this paper is the single paper which I have ever read for the fossil
Mhm.
files, at least, where with the most number of words that I didn't understand. Incredibly dense. I didn't make it all the way through.
Oh, okay,
Put my
that's all
hands up
right.
right
Well, I
now.
should have
It's a long paper.
now that I know that you have an AI unit and you're working on AI things, I realize I should have asked you to take the lead on this week rather than
No,
me. That was a mistake because you know more
no,
about it than I do.
I don't. I
Well,
don't.
ow. Okay, so let's have a look. So I guess the background is to helping us think about the differences between the different kinds of models of machine learning, deep learning, random forests. There's been a long, some of these terms that we hear banded around a lot, and I guess it's important to think about what they actually mean. One of the things that surprised me at the beginning, though, is that they highlight that this has been going on since the 80s, which was a bit of a shock to me, because I guess we always think about AI as something that is, and learning models and things like that. Has
I
been
know it's
going on
funny as
as a recent
well.
explosion.
Well, because our colleagues who were, doing paleo, I mean, maybe not so much in the 80s, but in the 90s, I guess most of our colleagues, who are the more senior colleagues in the field, let's say, they talk about, having to take some sort of punch card to some sort of room, and that was
Yeah.
like how they used computers. So it seems crazy that, there was AI going on when people didn't, they didn't have computers on their desks, but they were using AI. It's not a
I
bad
guess
thing.
this boils down to what you actually consider AI to be, right? A lot of the conversation that's gone on recently is about these new models of deep learning, but there were things going on before that based on, things like random forests or classifications or other kinds of, knowledge. What was the acronym they've used? Knowledge-based systems, which are a bit more simplistic, I guess, about making, sort of binary classifications, which is a lot more computationally simple. It doesn't require a lot of these things. But I guess it's interesting because these are different tiers of classification, and some of these things have been going on a long time. But as they highlight in this paper, one of the major sources that this has been going on for is microfossil classification. I've not done microfossil work before, but I work with and around people that have. Have you ever done any microfossil work before? No, you're shaking
No,
your head.
no,
But weren't
no.
you as a geologist, weren't you trained to use microfossils at any point?
No.
No.
I don't know. I think biostrat, back when
Yeah.
it was a very big deal in the oil industry, isn't it?
Yeah.
Actually, and actually anywhere where you're drilling. I was somewhere recently talking to somebody who did the biostratigraphy for the Channel Tunnel. So when they were drilling the
Wow.
Channel Tunnel through the chalk, in order to make sure that they were going at the right level, they had a biostratigrapher doing the microfossils in the chalk to make sure that
Nice.
they weren't going up or down too much. And apparently, it was the most stressful thing that this poor otherwise, presumably academic had ever
Yeah.
done. It was like making sure the French and the English sides joined up by
Yeah.
using microfossils, which
This
is pretty cool.
actually matters. Yeah.
So there's actually, there are lots and lots and lots of applications, which is presumably why
Yeah.
it was, developed for this. It's not just of academic interest, is it? Microfossil
No.
identification.
So microfossil classification is really slow work, right? So for those that aren't aware, if you take up your big load of rocks, maybe you acid prep it out, you get all these tiny little granules under the microscope, and you go through the process of photographing them and classifying them to different species. And this can have all sorts of applications, as Susie says. Oil exploration, biostratigraphy, but also evolutionary studies, right? Evolutionary studies and diversity studies might use this. But it seems like a really good candidate to do these sorts of automated classification tasks. Oh, that was the other thing. They define these three different roles that you can do with AI. Classification, where you might take an image or a sample and decide that it belongs to species A, species B, or category A or category B, something like that. Or segmentation, where you take a figure, an image, and sort of look at the edges, classify it, and sort of automate the sort of parts and anatomy of it. And then finally, prediction, where you might take some data and then, well, predict, quite frankly, like a weather forecast. And the classification of microfossils is very much within the classification zone. So you've got these hundreds of thousands of little tiny fossils, and you might want to ask the computer, can you tell me what species they all belong to? And if you can get that working, then you've got an amazing pipeline to get that done. So there's been quite a lot of those. That's where a lot of this is starting in a paleontology kind of level. So they present some nice examples that have happened in the past. Let's see if I can find my notes. Nope. I can't find my notes. So they introduced in this paper, they've introduced some examples of where this has been used before, not specifically for microfossils, but for, taking fossils and classifying them. So they talked about ImageNet, where there's 30,000 images of thin sections of fossils of different things, and they were able to get a 90% accuracy of classifying those. They also mentioned another one, which was 400,000 images from fossils of AI fossils. But ironically, when I tried to go and access it this morning, if that is not available, let's see if AI Fossils is back now. AIfossils.com. No, gone. But anyway, that achieves about 80% accuracy of classification, if I remember correctly. So you have to train these things, right? So it takes quite a lot of time to get the data sets for these. And they highlighted in their review article that actually it takes a long time between these models being developed and they're actually being applied in paleontology, like 5, 10 years, 20 years in some cases, because in some cases you need to do it. So, and also one of those done with dinosaur footprints. So that's one you mentioned earlier. That was 1,000 dinosaur footprints. Can it do it? Now that's a bit harder for dinosaur footprints. And that doesn't surprise me at all, because as we've talked about when we did our footprints thing, how do you know it's a footprint and not just some scratch on a rock?
But also, why?
Why?
I get the, well, yes, because I get the point with the microfossils, because there are,
Mhm.
I can see there's applications for needing to know what a microfossil is, but there's not that many footprints, Rob, and
Right.
they're not that hard to tell apart. Just look at them and go, yes, an ornithopod. Yeah, it's a theropod. But so it's just, I
Yeah,
don't
well,
know what
can
the
you
point
presumably
is.
automate? Like maybe I send my drone up into the sky and I can take loads and loads of images of the surface and therefore ask it where the dinosaur footprints are, and then I can go find it quickly. Would that not be good?
I mean, it would have to be quite a big track surface that's quite
Hmm.
extensive with lots of footprints that would make that quicker than just walking around and looking at them, wouldn't it?
Hmm.
I mean, I don't know. Sure, okay.
You're
I
not
just don't see what
you're
the. I'm completely unconvinced that this is worth doing.
you're not excited by that prospect. I think it
No,
could be fun if you get it. I
I
mean,
I
also I guess
actually
automation is going to be important, right?
a thing that you should know about me that I'm not excited about in general is
Yeah.
dinosaur tracks. It's the thing I'm not
Oh,
excited
right.
about.
Okay. Well, what if it was dinosaur teeth? So that was another example they said from a friend of the fossil file, Simon Wills. I say same friend of the fossil files. I don't know if he listens, but we had dinner with him the other day. He's
He
got
is our friend.
1,000. He is our friend. He has 1,700 dinosaur teeth images, which he was able to classify to some level of accuracy, at least to family. So that'd be fun.
So that he's done a couple of studies which are actually really interesting, I think,
Mhm.
because what he's done is he's taken kind of historic data that where people were like, we don't know, these are just generic teeth, so they're sort of indeterminate teeth. And actually, what he's been able to do with his AI is suggest that there were taxa that we didn't previously realize. So not down to genus level, but down to broad clade level. So what he was able to
Mhm.
show, for example, is that there were dromaeosaurids in the Middle Jurassic of the UK, which we didn't already know. Now, dromaeosaurids should be around in the Middle Jurassic, but we just don't have a very good body fossil record of them. So it's kind of, he's been able to show that there was more diversity at the clade level in Middle Jurassic than was previously had been identified by people just looking at these things
Oh,
by
that's
using
fun.
AI. So I think
I mean,
that's a good
that's a good
application.
example, right? We can fill in the gaps, but then again, this highlights the point, right? How much is I guess what I'm framed this whole idea about are we going to go extinct? But so far, all the examples we've looked at are making things a little bit easier and filling in the gaps, rather than say revolutionizing the field and generating new ideas. But we'll come back to that. So they also mentioned this really interesting example where they've got a lot of the things with macrofossils. So now, if we move on from microfossils and start thinking about the big things like the dinosaur footprints, the dinosaur teeth, when you're dealing with big things, and it's a very different kettle of fish or a kettle of insects, as it were, because you're dealing with a much different, complex, more difficult kind of information with different kind of scales. And they highlighted that in this paper. They highlighted this one called PestNet, which was on 500,000 pictures of modern insects, and that can do it with 75% precision. So they start talking about precision and accuracy a lot, but it leaves me wondering, is that better or worse than a human? If they can identify these 500,000 insects at 75% precision, is that enough? I don't know.
Yeah, well, it depends what you want to do with it, doesn't it? And I mean, the other thing, so a big problem I have with this, just fundamentally, whether you're applying it for microfossils or for insects, you and I are both taxonomists,
Hmm.
at the most basic level, aren't we, Rob?
Hmm.
And, you know, I know that I can go and have a discussion with people who work on stegosaurs from Spain and
Hmm.
have
Hmm.
completely different idea of how many taxa there are in the late Cretaceous of Europe, the late Jurassic of
Mm.
Europe, based on the same fossils, right?
Yes.
So I say, no, this is a different, that these are clearly 3 species. Whereas the Spanish will go, no, 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 they're all 1 species. So if me and them can't even agree,
Hmm.
how is it that how are we if we do train them, how am I going to train them? Am I going to
Hmm.
train my biases in?
Hmm.
So, and for forams, I mean, we know that, forams are the microfossils that have been used
Hmm.
quite heavily in for AI identification by
Hmm.
at least according to this paper. And we know that we have evidence for anagenically evolving lineages within forams,
Hmm.
by which I mean that, it is really difficult to
Hmm.
put things into species envelopes. Species are inherently a human construct because
Yes.
things change gradually over time. That's the nature of evolution. And with the foram fossil record is so good that we can actually see this change taking place in the fossil records. We
Hmm.
can see
Hmm.
one species evolving gradually by a repeated series of changes into another species.
Yeah.
So if we can't even draw lines between them, how is
Hmm.
AI drawing lines between them?
So yeah, I think that's a really interesting point. That raises 2 things, I guess. One is that I should have explained a bit more about training data sets, about how this works, right? So to get these models to do anything that you want them to do, these classification studies, you need to present it with so if there's 500,000 insects, someone needs to somewhere go through as a human and say, okay, that one's species 1, that one's species 2, that one's species 3. And then the software, the models, the deep learning networks will look at those images, identify the characteristics that will allow it to say, okay, I think that one belongs to species A, species B. And then when you give it some new information from ones that weren't in the training data set, it will then classify it using that same sort of characteristics. Now, that's where the slight difficulty arises, because there's a sort of black box going on inside where we don't know what it's doing or why. All we're doing is some human has had to make a decision at the beginning with that training data set that this belongs to species 1 and this belongs to species 2. And
Right.
that relates to the second point I wanted to mention, which is the really important point you mentioned about taxonomy. In that taxonomy it takes a lifetime of training often, and isn't necessarily prioritized and valued as a scientific discipline in many ways, at least not as far as grant funding councils are concerned, unless, because they want to fund big picture scientific stuff. Whereas if you're saying, I want to figure out, update the taxonomy of this particular family of fungi, they're like, well, okay, well, so what? That's not important. That's stamp collecting is the derogatory term that's often applied. But so that's one problem. But the second problem is lumpers and splitters. There's always been an ongoing concern, right? My brain
Well,
stopped again.
what it is the
Mhm.
problem is that species are human constructs, as I said,
Yes, yes.
right? There are really, what we have is populations that live, you know, with each other, and
Hmm.
those populations vary to some extent. But how much variation do we have to form a new species is qualitative. It's not it's subjective.
Hmm.
And one taxonomist, particularly when we're talking about morphological taxonomy. So we also need to say that, of course, with living things, we can do DNA. Now, still,
Hmm.
DNA, it's still subjective how much DNA difference there needs to be.
Yes.
But we can have like biological kind of definitions of what a species is, like 2 things that breed to produce viable offspring.
Hmm.
Again, that's not that doesn't work either, because things can be introduced to each other
Hmm.
artificially and then breed that would never have met in nature. So there's all sorts of different issues around species concepts. But if we're talking about paleo, then of course
Oh,
we
it's
can't
even
use
worse.
any, yeah, we can't use
Yeah.
any, we can only look at morphology. So how different does the 2 things have to be different species is totally subjective. And it differs across different fields as well. So what you as a fish guy might say, well, this is the amount of change that in
Hmm.
fish we sort of require. I might
Hmm.
say in dinosaurs, I might say with my dinosaur hat on, come and look at your species and go, oh no, bollocks, they're the same thing.
Hmm.
Or vice versa, you might come to our dinosaurs and say, well, you massively oversplit. And even within dinosaurs, there are different groups of dinosaur that you work on. There are
Hmm.
different kind of taxonomic practices. So it's really, and a lot of it, I think, it depends on how good your fossil record is.
Yeah.
So the further back in time you go, I sometimes see that there are species or genera particularly that might have been around for 30 or 40 million years. And I just think in dinosaurs we have none
Yeah.
of there's no
No.
genera that are around for 40 million years. What are you
Yeah.
talking about? It's ludicrous. So it's really, really, really subjective. Now, I could take my view and train an AI on my view,
Hmm.
but that's just my bias, isn't it? How does that make the AI any better than me just doing it? It might make it quicker than me just doing it, but it's not the answer, is it?
Well, this leads to I completely agree with you, but this leads to bigger questions for both AI and taxonomy, right? So the AI, this isn't just for paleontology, but for all of AI, it's going to boil down to the training data set, right? What have we used for the models to learn from? It's going to be riddled with biases because it's human information that we're constructing. And indeed, ChatGPT or Grok, the Elon Musk one, is seemingly having biases built into it from the beginning about how they want it to go. Is it going to be picking up the way that we talk about things in terms of our expectations of gender or race or whatever? It's going to be based on what people have said about gender and race before. And when it comes to taxonomy, it's going to be based on things that people have said in the past about being a splitter or lumper. And it's going to be the decisions that it makes on the trained data set are based upon what that person has chosen to do it. So with paleontology, I guess there are extra problems there. I mean, I would suggest from my outside perspective that dinosaur people are massive oversplitters. With oh, this tooth is from a valley along. It's a different species. Can you not just tell just by looking at it? A lot of people take a lot of pride in giving erecting a new name and saying, "Well, this I've named this new taxon. It's my new thing." But that's not just dinosaur people. Everyone's guilty of that, I guess. But one fossil example they mentioned in here was paleo wood, which was classifying fossil wood from the Paleozoic, gymnosperm wood.
I thought
And
that was
this
quite
model,
a funny name for a
paleo
an
wood,
AI. I thought maybe they could have just, I don't know, run that past some like a focus group to see how that was going to go
yes,
down, calling
yeah,
something paleo wood.
yeah.
Okay, sure.
So the problem with that model was it couldn't distinguish between convergence and homology.
Yeah, so that's what I
That
thought when I was reading
yeah,
this.
yeah,
I thought exactly that. I thought, the big problem with this is going to be convergence.
yes. So convergence is when two unrelated things can evolve the same looking morphology. And if you're only looking at something like wood, that can obviously be difficult. But the same thing will be true of dinosaur teeth. If you're two herbivores from a different group, you might end up looking like quite similar teeth. And that requires some sort of taxonomic specialism in order to be able to get a handle on. And of course, there are loads of ways of answering that question. You can look at the things that are close related to it. You can consider the different things in there. But AI might, unless you specifically train the AI to mention all that extra contextual information, it won't be able to do that. And indeed, for something like a dinosaur tooth or a wood, that's going to be hard because you'd have to look at all the things that were close related to it or where it came from.
Well, but fundamentally, Rob, I mean, I guess the way that we identify convergence really is, particularly in closely related groups, is through
Yes.
systematics. It's
Yes.
through
Yeah.
phylogenies, isn't it?
Yeah.
We discover that they're not closely related, and thus we say, well, these two similar morphologies must therefore be convergent. But
Mm-hmm.
that's a conclusion of our phylogenetic analyses and our
Mm-hmm.
systematic analyses, looking at
Yeah.
who's most closely related to who. But are we going to feed in a load of marine animals into AI? I wouldn't be surprised if they think that ichthyosaurs and dolphins are closely related, right? Because they look
Mm-hmm.
the same, but they're not
Mm-hmm.
closely related in
Yeah.
any way at all. So,
Yeah. Absolutely. So those are the examples from the classification routes. Segmentation, I'm going to present a separate example for you, but they also mentioned an interesting example for prediction, which was looking at mimicry. So the idea is that, okay, if you're insects, you might evolve all sorts of mimicry, but you don't necessarily know what they're evolving to. So they did it with our old friend Maya Amber.
oh yes,
Sad noises. But they were able to make predictions about what, that's an interesting one where you can predict, okay, this organism looks like this, which is unconnected potentially to this previously unconnected organism. So, you could look for things that they're mimicking potentially, which I thought was kind of fun. That's an interesting use of prediction there.
it is. I mean, I guess I didn't read this far down the paper. I'm going to put
Uh-huh.
my hands up right now. Got. I was done. But the mimicry, the Myanmar amber issue is that
Yeah.
those fossils, I mean, they are exceptionally well preserved, right? Those
Yes.
insects. So this isn't something that presumably you're going to be able to do on a beetle wing case from the Wealden group. This has got to be something that's exceptionally well preserved. So how many
Well,
cases is this? I mean, how broadly applicable is this? I guess what I'm saying.
that was one of the things I wanted to talk to you about actually, because the authors of this paper put together a sort of perspective and thought, think about the future. And one of the perspectives I was going to insert my own opinion on here was that a lot of the training data sets are based on living groups, living insects, living pollen, things like that. But I think the real difficulty is going to come when it comes to paleontology is taphonomy and missing data, right? That's
Yeah.
something that we are trained to think about all the time, and it requires human eyes. AI at the moment is seemingly unable to take that into account because taphonomy can lead to real big distortions and changes. How that information in your fossil is transformed during the fossilization process can be really weird, and it could vary from site to site. It can vary from place to place. It can vary from taxon to taxon, and it requires an awful lot of thought and consideration. Now, that doesn't mean that humans necessarily are good at it. As indeed, some of my papers have demonstrated that humans can be bad at taking into account taxonomy, and that can distort the information they get from that fossil.
Talking about dinosaur researchers being oversplitters, some of the most probably oversplit clades are almost certainly, at least in my humble opinion, because those people haven't taken into account taxonomy and thought about how things get squashed and how they come out of the ground.
Yeah. So that was where I said I think the problem is going to arise, but that doesn't mean it's not a problem that can't be solved. It's a problem that could be solved, but it is going to require an enormous training data set where the people wouldn't necessarily be able to agree upon, as you pointed out, humans are going to vary in their ability to interpret that data as it stands now. So we're not currently at the stage that a training data set could be constructed unless we sort of sidestep that issue. So let's have a look at some of their results. They said that they looked at the results of AI studies in paleontology that have been done so far as of 2024. 1/3 of them were on foraminifera, 1/3 of them were on microfossils, or other microfossils, and 1/3 was on everything else. They said that there was a big gap between the development of the models and the application. And they said that there was a big uptick in studies in 2015. That was where there was this sort of change point. Although even then, in the most recent year in their study, there was only 16 studies per year. So 16 studies per year is not yet a revolution. I guess the point is that we're on the cusp. We're on the cusp of seeing a lot of papers about AI and paleontology. And what are they going to do? How powerful are they going to be? They lay out some interesting examples and ideas to consider that. So what do you think the future is going to be?
I'm not worried that that AI is going to make me redundant anytime soon, I have to say. What I was thinking though is actually how we are increasingly using AI in our work, although not to do our work.
Yes.
So some recent examples of things I have done using AI. Coding.
Oh,
So,
right. Well, coding, yes, yeah.
coding in R, my very basic use of R involves me having R open, and then every time I want to do a command, I have to Google what it might be. Whereas now you can ask ChatGPT to what is the code to do this particular thing, and it comes up with some code. And I mean, you have to have a good enough knowledge, right, to sort of double check that it's actually doing what you want it to do.
Well,
But
that's a really important point, isn't it? Is it doing what
yeah,
you want it to do? And I think that's something we tell our students actually, is that for education. I was thought we'd have time to talk about education, but we were already I don't think we're running out of time anyway. Was that this is a real big challenge in how you examine and evaluate students and what they can do in terms of their work and their essays. We have to really transform the way we do our education. But the coding is an example that I can mention to the students, right? You can and maybe even should use it to generate code and look at it. Now, you do have to go back and look at it doing what it's doing, but it is very good at that. But that's because that's the sort of thing that it can have the training data sets in order to be able to make it work. It's not the same as generating text, the text generating ones. And that reminds me of something I forgot to mention in the thinking about text versus figures. It's something that I must mention in the paper, that when you're dealing with these large amounts of future models of automation of figures, with respect to dealing with morphology, they pointed out that morphological descriptions, as written down in a paper, are often incomplete enough for AI to work or to reconstruct the anatomy of something. If you're saying the tibia is long and convoluted and curves to the left, and the left flange, that's what I imagine dinosaur people write about their tibias.
exactly what I write.
Exactly that. But that's not enough for a large model to work on. Whereas the problem is there's a gap, because the other end of the scale is the large 3D data is too big. If you upload all those scans, they're too big, and the models can't really work with that. So there's a gap with the right size of the data for it to work within for the models is in between, where you have some sort of more simplified model, potentially from the photos. But again, the photos can be taken from different angles and can be subject to toponymy and missing data, which is always going to be a problem. So those are the examples of things that you've been getting up to. The other one we haven't mentioned is paleo art, I guess, art and art generally.
yeah.
I mean, that's a whole subject in and of itself, where the training data set that's being used by a lot of these people is going on around the literature, around the data internet, harvesting all these images that are copyrighted and take a lot of time to image, process, and create. Artists are doing this for a reason. They're getting paid to do it. And then that's getting scraped, and now you can just ask AI to generate a nice picture of a Tyrannosaurus Rex, even in the style of your particular favorite paleo artist. So those data are being harvested and imaged, are being used without the permission of those people and against their wishes. That's going to be a big problem.
So funny story, right? the other day, okay, I'm going to try and leave this name free, but I strongly suspect that the relevant people will not be listening to our podcast, Rob, because,
Okay.
well, so I was giving a talk at a local geological society, and
Mhm.
one of the people in the audience had done some work on some fossils in the NHM's collection, in that he had traced them to being from where he lived, close to where he lived, and he'd asked me to do some research to see if I could find these fossils in the collection with very little information. And remarkably, I had managed to track them down, and actually it was very useful because I was able to go, oh, look, these random bits actually belong to a single specimen, and we didn't know that before.
Mhm.
So that was interesting. He said
Mhm.
very excitedly, and I've got I don't know, Neil or whatever to do some art for me for it.
Mhm.
And I looked at the picture that he showed me, and it was immediately obvious that this was not an iguanodontian dinosaur.
Mhm.
But also it had 3 back legs.
Oh no.
And I said to him, I said, is it AI? And he went, oh yes. And I said, and it's got 3 back legs. And they all creased up and they all laughed, and none of them had noticed.
Okay.
But
I
anyway,
think that AI and
it's
paleo art
obviously
is
not very good, yeah, is it? I
no,
think.
no. I think AI and paleo art, or art in general, is a whole different topic that I think we're going to have to go off on another time because, well, if we need to, because that's a whole separate problem with copyright and accuracy and all those sorts of things. But that is an interesting example about how it's not ready. It is
Yeah,
not ready to
yeah.
generate
It's
these
just
things.
not ready.
But
Um,
expect the internet to be full of it is the problem.
Yeah, absolutely. And actually, we had my dinosaur that we spoke about that came out earlier this year,
Mhm.
Spicamelus. The artwork was done by my former student Matt Dempsey, who's a
Mhm.
really talented
Oh yeah,
paleo
yeah, yeah.
artist and does
Mhm.
really cool kind of digital modeling in really interesting ways. The number of people who asked me whether it was AI generated was insane.
Oh, ouch.
And
That's a
I think
slam to
it's,
Matt. He's so careful and
yeah,
dedicated to the work that he does. It takes ages for him to create those models.
I mean, ages and ages, but I guess it's the digital look of them, because so many
Yeah.
artists, the paleo artists these days are doing,
Mhm.
they're not doing paintings, right? It's
Mhm.
digital modeling actually is what they
Mhm.
do.
Mhm.
That people are, us as humans are very bad at distinguishing
Yeah.
what's real and what isn't actually as
Yeah.
well.
So I think that's something to think about for the future. But I did want to present you to a couple of examples that I haven't sent you in advance. So I'm doing this on the hoof of examples where paleontology and AI has been used in an actual paper.
After that time where you sent me a picture of a penis, it was a rock. It was a rock shaped
It
like a
was
penis.
the Earth Food Maniport is a very important and serious piece of research. I wasn't just sending you things that's going to be work that's going to be cancelled with HR. Let me send you a couple of pictures now. So this is the question about whether or not Homo habilis, was being eaten by leopards or not. So Homo habilis is a fossil human from about 2 million years ago in Africa, a sort of transitional human species. And there's debate about whether or not it was an apex predator or not. So here are some skulls of Homo habilis with puncture marks in its head. So the question is it an apex predator or is it being eaten by leopards? So I'm going to send you this picture now, which I guess is interesting in the paleo art perspective. I have no idea what this image makes me laugh because I have no idea where it's come from. I can only find it on Facebook, which is not very secure. So
I
this,
don't have Facebook, so you might have to screen grab it for me.
okay,
Oh no, I've got it. Oh, gross.
we've got this
It's
sort of
actually
Homo
worse than the
habilis.
penis. Oh my God.
I'm reluctant to publicize this image because I don't know where it came from. But we've got this. There is some real fossils with puncture marks seemingly on the skull, and then this idea that this leopard might have been puncturing the eyes of this particular Homo habilis. It's a very
But
sad looking creature.
this is some sort of, it looks like a kind of, it looks like what Hollywood might
Yeah.
dress an early human up like. So it's a sort of
Yes.
ape-like hairy
Yes.
thing, and
Yeah.
it's a leopard with its fangs, its
Yeah.
canines puncturing the eyes of this poor thing, and it's obviously got its mouth open in a, I guess, I mean, it's in a scream.
Now let me send you some actual science to go associated
Oh,
with
good.
this.
Okay. Okay.
Okay, so the
Homo
paper is
habilis.
Early Humans and the Balance of Power, Homo habilis as Prey by Marina Vergara Requiem and some colleagues from Spain. This is in the Annals of the New York Academy of Science, separate from that dodgy New York Science Journal. This is an actual bona fide publication. not the same one that we looked at, the fossil dinosaurs on the moon, which was
Not a
so
bona fide publication.
not a bona fide publication. So in this paper, they look at this Homo habilis mandible and another bit of Homo habilis, and they have found some puncture marks on these, and they submit a training data set of bite marks from modern groups that have been, bite marks of bones that have been bitten by hyenas, wolves, lions, that sort of thing. And then they've asked that once they've created that training data set, they then apply the morphology of these sort of triangular puncture marks in this Homo habilis bone and ask, is it a predation mark? And what was it that was doing it? And they found that the data set was about 80% accurate from the training data set, which, is, I guess, well, is that good or bad?
Is
I
it
don't know.
accurate enough? Yeah, I don't know.
And then
Okay.
and then they submitted this one puncture mark of this Homo habilis, and they said, yes, it's a high probability, 90% plus that this is a predation thing, and it was most likely, with a high probability, a leopard that was eating it. So that's interesting. But I guess that does raise the question about taphonomy. If you're training the data set on things that, how are you able to identify what is and isn't, what a fossil would look like, and how accurate it is? But I thought this was an interesting example of classification in paleontology to answer an interesting evolutionary question, which is important, right?
It raises
You don't
all
think so?
sorts of questions to me, Rob. Well,
Yeah.
given that that the first paper that is the kind of the one about today that we're talking about
Mhm.
spends a lot of time saying about the kind of human effort, the upfront effort of developing a training data
Mhm.
set,
Mhm.
and actually training the data. And this is a clearly very time consuming process to get that.
Mhm.
How many human fossils are there that this could be applied to? So they've developed a
Ah,
whole
yeah.
AI
Mhm.
to
Mhm.
identify one fossil. Just
Mhm.
seems, I don't know, is it to answer the question whether humans may or may not have occasionally been, I mean, just because this one doesn't
Mhm.
mean that habitually
Mhm.
leopards were preying on humans, does it? I mean, but also
Yeah.
if I it doesn't, like, so this one,
Well,
this human got eaten by a leopard. Probably
well,
sometimes humans did get eaten by leopards. I mean, I don't know that we need AI to tell us this. It's just
well,
not that interesting.
well, I think it is interesting because I think it's, the hypothesis about whether Homo habilis was or wasn't the apex predator or was it a tool making, the question is, when did humans become the apex predator? Is an interesting and important evolutionary question. But I do absolutely accept your point about the amount of effort taken to create this data set that is quite narrow, right? So it could only answer this in this particular situation. Although I guess in theory it could then be opened up to looking at all humans, not just the particular two.
Yeah,
So
but
I guess
how many
what?
human, there are hardly any human fossils. I mean,
Mhm.
this is why anthropologists hate each other so much, right? Because there's hardly
Yeah.
any fossils, so they're arguing over like 5 fossils all the
Oh,
time.
lumpers
Uh,
and splitters. Well, the anthropologists are a crazy bunch in that respect.
right? So I mean, I mean, there's what is it, the Huang child, the one with
Yeah.
it has the eagle claw marks in its
Yeah.
skull.
Yeah.
So
Mhm.
there's that one. I mean, I guess we know already that animals sometimes ate humans. I don't think it answers
Mhm.
the question of whether something was an apex predator or not, because one of them has something in it. But
Yeah.
we hardly have a statistically significant sample size to test that, do we?
Well, that's one.
Anyway,
I
let's
guess
move
they
on
would
to the
say
next one.
the second example is one that I guess is probably a really useful one, which I've just dropped into the chat. So that is by Epson, Knudsen, and Dmitry Konolov in Scientific Reports in 2024, Accelerating Segmentation of Fossil CT Scans Through Deep Learning. So this is something that a lot of paleontologists spend their time doing, which is when you get a CT scan, you have to manually go through, often manually. I mean, you should potentially be able to automate it, but you end up with all these slice data of your scan. You've taken your fossil, you've put it in the CT scanner, you've got thousands and thousands of two-dimensional images of it, and you have to go through the slow process of converting that into a three-dimensional image and separating out rock or shells from the rock matrix, thinking about the shells or the bones. Now, they did an example where they can try and make this more efficient by using a training data set. And actually, they found out that these results on this sort of skull, I don't actually know what the
The
fossil is, a
procolophonic
proleucophone, no,
skull. Yeah.
parareptile skull, and they actually demonstrate that they could potentially make the work more efficient. So that's interesting because that actually means that you could save people a lot of time and energy potentially to do that. And I guess the interesting example here is that this is potentially scalable to lots of different examples, but I guess you'd need to create a training data set each time you're doing it, specific to your fossil and specific to your matrix, specific to
Yeah,
the scanning equipment
exactly,
you've
Rob.
used.
So actually, there's a piece of segmentation software that lots of people use. I think it's free, called Dragonfly, and it
Hmm.
already uses some AI tools to help with segmentation,
Hmm.
to auto segment. So I guess some aspects of this sort of thing are already being
Hmm.
embedded in segmentation software. And this, but what you just said is exactly the problem. So quite a lot of people are working or have worked on this idea of being able to segment, so auto segment. And
Hmm.
actually that's the same as the project that I'm kind of, as I said, I was tangentially involved with, is doing exactly this as well. But the issue is that every single matrix, there are places where, it's very, very difficult to even see any bone when you've got it's easy when your fossil hasn't got any filling, when it hasn't got
Hmm.
any matrix surrounding
Yeah.
it, any rock surrounding it. But when you have rock surrounding it, the properties of the rock are different. And that means
Yes.
that the contrast between the fossil and the rock are different in every kind of
Hmm.
scenario, right? So you're going to
Hmm.
have to do this for every single different, at the moment at least, every
Hmm.
single different formation that you're finding fossils in.
Well, I wanted to give you some real world examples so that we can get our teeth into it, no pun intended, about what the, actual applications of these could be beyond just the review article, just laying out some of the future. There was a third one which didn't have time to read, but I could at least mention it, which was working with occurrence data and diversity curves through time. So this is much more of the big data approach, where we got this paleobiology database where we can reconstruct massive diversity curves of mammals through time and things like that. And this deep dive R package by Rebecca Cooper and Bethany Allen and friends was the way to sort of take that data and sort of fill in the gaps that, often it's things like, okay, we've got all this data from North America, but South America is massively incomplete. How can we correct for that and estimate what the diversity curves might have been? But I didn't have time to read that one, but it might be an interesting one to go and have a look at.
Yeah.
So there's three different applications there, potentially looking at bite marks, looking at deep diversity curves through time, or making your segmentation a little bit quicker. So let's take a step back then and think about, because we've been talking too long, what do you think the future for AI and paleontology is? It doesn't sound like you have great optimism or hope.
No, that's not true. I think that it's going to make lots of our mundane, boring tasks faster. So
Hmm.
as I listed some of the sort of mundane, boring things that, we have to do on a day-to-day basis, I think segmentation is,
Hmm.
something that will definitely can be sped up. I think language correction. I mean, many AI tools, things like Grammarly, right? People are already using, and it's
Hmm.
completely acceptable to use those to,
Hmm.
do your grammar, to sort your grammar and your spelling out and stuff like that. So
Hmm.
I think that there's lots of things that will help us and will make our lives easier. I think
Hmm.
whether we're going to get replaced is a different question. And it's interesting. I was talking to somebody about this the other day about, whether, because these tools will help speed up our jobs, that means we should be able to do more, which might
Hmm.
mean that there need to be fewer of us potentially.
Hmm.
So, can you could envisage a scenario, or I could envisage a scenario in the future where, you might have a grant that requires segmentation of lots of fossils, and thus you employ, say, 2 postdocs on that
Hmm.
project to do lots of the segmentation. And actually, if you yourself could just upload that data and just
Hmm.
go enter, and then it segmented it for you, you would
Hmm.
no longer need a postdoc, would you?
Yeah.
So I can see that there might be a place where actually that fewer of us are required. But what I haven't seen clearly yet is that there's a way to do taxonomy, to do field
Hmm.
work, to find fossils, to do sedimentology, to, do the sort of basic underpinning foundational work that our discipline
Hmm.
relies on. And I think, that big data, we didn't talk about that big data
Hmm.
project. Again, lots of people in our field have moved away from this foundational kind of work that we do, the
Hmm.
taxonomy and systematics, and are taking the data that taxonomy and systematics generate
Hmm.
and then applying big data questions. And that's the sort of work that's getting funded a lot. But
Hmm.
I also think that it's those sorts of people who may find that they're out of jobs, because
Ooh,
AI
yeah.
we can replace
Hmm.
them actually, because they are not generating the basic, most foundational data.
So two thoughts there. I think looking ahead to the future, one of the ones we didn't mention was actually, as you've one of the common fossil files mantras from you is that, well, not you specifically, us, I guess, is that, you need to go out and find these things in the field and do some field work to generate the new data that everyone needs downstream, whether you're doing evolutionary analyses or big data analyses. One of the potential ones is using this in a prediction sort of sense, is getting drone footage of a particular site and asking, okay, what does the landscape look like? Where are the predictions of where I could or couldn't find the fossils? And indeed, that can be done on a large scale. I've been doing a project with Jane where we can try and think about, okay, let's make some predictions about where we think fossils are not going to be
Hmm.
preserved, to make some prediction informed field studies about where we could go and maybe identify areas that have been overlooked. But that is going to require people, that's going to require boots on the ground, because AI is not going to go and dig up those fossils. But I think thinking ahead to the future, I think scientists are pretty safe, because the AI is not capable, as we've demonstrated with these examples, it is creating pipelines that might automate the work. It might even classify things. It might segment things. It might make predictions, but it's not going to generate new ideas. We're not at the stage yet when that's really what our job is, to identify novel connections, identify new theories, and test those theories. It
Well,
doesn't
you
seem to
say
me.
this, Rob. So
Yeah.
actually, so last year I was out in the field in Mongolia with a really
Hmm.
interesting group of people.
Hmm.
And one of the guys there, Todd, hi Todd, Todd's not listening. Hi Todd.
Hmm.
We had exactly this discussion over one evening, and
Hmm.
he said, "So do you think AI is capable of generating novel ideas?" And I said no. And so he went away unbeknownst to me and entered in to, I think it was ChatGPT, might have been Gemini, come up with come up with a research proposal for a grant based on the work of Susie Maidment. And he came back and he had 3 or 4 of these. And actually the first one he didn't tell me this either, but he said that sounds plausible for non-specialists, but is massively flawed for a
Hmm.
specialist.
Hmm.
And it worked really, really well. So he
Hmm.
basically anyway, but the ideas that he came up with, interestingly, they weren't super novel,
Hmm.
but they were novel enough that I was like, actually, I've got a PhD student who's doing that, and it's possible that, of course, that idea had been culled from some sort of website where we'd advertised a
Hmm.
PhD or something
Hmm.
like that. So it wasn't totally novel. But I've got to say, they were definitely ideas that would be, that you could see in a grant. So I don't know about that, Rob. I think that
Well,
I
I
think,
guess maybe I'm being naive there. I guess there's different tiers of plausibility of a new idea. Is it a new idea in reality? Is it a new idea according to peer reviewers? Is it a new idea according
yeah,
to grant panel reviewers? Those
yeah.
are 3 different tiers of what plausible sounds like. And I guess we're going to find out soon enough. But are those grant proposals going to be generated using ChatGPT? Are they going to
Well,
be evaluated using ChatGPT? And is a human going to be better than a robot in respect to any of those things? That's a different question, but we're going to find out. Well,
that is
let's
a
look
difficult
forward to the
question.
entire discipline wheels of the bus coming off for all of science. But surely it's our job to come up with novel connections that a computer can't make, because you have to connect part A and part B. And, and a computer, it can't do that because it can't look at it can identify gaps, it can classify things. But in order to generate something truly novel, seems to me that that's not really possible with the current networks. That's not how it works.
Yeah, no,
But
I agree. I do agree. Yeah.
maybe I'm misinformed and I'm about to be replaced, and we'll see. Well, we can create the next episode of Phosphors in the dole line at the unemployment queue. I'm thinking about
That's true.
what we're going
Think
to
how
do
much
with
more
this.
time we'd have to do podcasts, Rob.
Well, AI generated podcasts are definitely on the way, so look out for that.
Yeah.
All right. Well, thanks, Susie. Our next episode, I think we're going to be having a 2-parter with our sit-down interview with Steve Brasati about new dinosaurs from New Mexico. So look forward to that, everybody. We've got that episode in the bank ready to go. If I can actually sit down and edit it, or maybe I can just ask AI to sit down and edit it for me and take out all my silly noises and wincing when I laugh at my ribs hurting as you make me cackle too much with bad AI jokes. Well, thanks, Susie. Any final thoughts before we move on?
No, I'll leave those to AI.
Ow. Ow. All right. Thanks, Susie. See you soon. The Fossil Files was presented by Robert Sansom and Susanna Maidment. You can find more information, including links to the original papers that were discussed, at fossils.libsyn.com, and you can contact us at fossilfiles.pod@gmail.com.